Apparently, Tesla is indeed preparing one of the craziest automotive announcements in its entire history. And this time, it is not about a new $25,000 electric vehicle, a robo-taxi, or even a new generation of Optimus. Elon Musk's company, according to several sources, is approaching the presentation of the new Tesla Roadster, and the climax of the event could be a moment that would have looked like a scene from a science fiction movie just a few years ago. The car is supposed to lift off the ground using a rocket-powered system developed in collaboration with SpaceX. Reuters, citing the information, reports that the demonstration could take place as early as August 2026 at the SpaceX testing facility in McGregor, Texas. At the same time, this is supposedly not simply another version of the electric sports car. Tesla is reportedly preparing a special limited edition Roadster equipped with a SpaceX cold gas thruster system. According to available summaries of the information's investigation, Tesla gradually moved away during development from the idea of something almost resembling a true flying vehicle toward a much more realistic concept of brief hovering. One source described the evolution of the project roughly like this. They started with something practically resembling an airplane and eventually arrived at something much closer to hovering, meaning a short period of suspension above the ground. But even if the Roadster rises only for a few seconds, it would still be an extremely unusual engineering achievement, because this would not be a quadcopter with wheels or a conventional eVTOL with huge propellers. Tesla is attempting to make a heavy road car lift off the ground using a system of nozzles that eject gas at enormous pressure. And the history of this idea began far from yesterday. The new Roadster was first unveiled back in November 2017. At the time, it was a beautiful red electric sports car that was supposed to enter production around 2020. Tesla promised specifications that seemed almost impossible in 2017. Acceleration from 0 to 60 miles per hour in 1.9 seconds, a top speed of more than 250 miles per hour, and a range of around 620 miles, or approximately 1,000 kilometers. Interestingly, even now, in August 2026, Tesla's official website continues to display exactly these figures and images of the old concept. The website still lists 1.9 seconds, more than 250 miles per hour, and 620 miles of range, but as early as 2018, Musk unexpectedly announced what became known as the SpaceX package. The idea was to install approximately 10 small cold gas rocket thrusters around the vehicle. They were supposed to help not only with acceleration, but also with braking and cornering. According to the original concept, the high-pressure system would occupy the space behind the rear seats. Tesla later mentioned the SpaceX package itself in its materials, linking the rocket thrusters to the Roadster's extreme acceleration. To understand how unusual this system is, it is necessary to explain how it works. A conventional rocket engine burns fuel and ejects extremely hot gas. A cold gas thruster is much simpler. A special, extremely strong tank contains gas at enormous pressure. When a valve opens, the gas exits through a nozzle at high speed and generates thrust in the opposite direction. No large flame is required for this. It is very old and well understood physics, and similar systems have long been used in spacecraft for attitude control. But installing such a system on a car is an entirely different matter. The Roadster's mass is measured in hundreds of kilograms, not dozens like a drone. To lift the car vertically, the combined thrust of the thrusters must at least equal its weight, and that alone is not enough. The system must continuously control the vehicle's position in roll, pitch, and yaw. If the thrust from one nozzle differs even slightly from another, the car begins to tilt. That means the system will require extremely fast electronics, position sensors, and a control system capable of adjusting thrust almost instantaneously. In fact, during such a mode, the Roadster stops being an ordinary car for several seconds. Its tires are no longer holding the vehicle on the road, which means the familiar ABS, traction control, and electric motor torque control systems are no longer solving the main problem. Tesla will have to control the vehicle's movement almost the same way a control system manages an unmanned aerial vehicle. And this is where it becomes clear why this presentation has been repeatedly delayed. According to the information, the rocket-powered system project inside Tesla was given the codename A71. At the end of April, Tesla and SpaceX employees had reportedly already shown Musk an early version of the system, Yet the public demonstration continued to be postponed. Back in November of last year, Musk promised a new Roadster presentation on April 1st, 2026. The timeline then shifted, and during the first quarter earnings report, Musk spoke of roughly another month of waiting, while in June reports emerged that the demonstration had been pushed back to August or even later. And literally just a few days before the latest information appeared, Tesla's chief designer Franz von Holzhausen spoke about the car again. During Jay Leno's garage, Jay Leno said that he was waiting for the new Roadster, to which von Holzhausen responded twice, very soon. He did not provide a specific date, but against the backdrop of the information's report a few days later, the comment looks much more interesting than an ordinary statement from a company executive. Even more interesting is something else. On August 12th, Musk responded on X to a joke about how humanity had been promised flying cars, but instead got artificial intelligence. Musk's response was essentially a promise. You will get flying cars. By itself, this proves nothing. But just 2 days later, a report appeared saying that Tesla was indeed preparing a Roadster demonstration with the ability to lift off the surface. The latest information also reveals an entirely new story about how the car was developed. According to sources cited by the information, several years ago, there were at least 2 development directions inside Tesla. One option involved using the Model S plaid architecture and essentially developing the original 2017 concept. Another team proposed starting almost from scratch and creating a lightweight carbon fiber monocoque based on the principles used in true hypercars. Musk, according to the reports, chose the second approach. And this is a very significant change. A carbon fiber monocoque is not simply an expensive component, it represents an entirely different philosophy of building a car. Similar structures are used by McLaren, Lamborghini, some Ferrari models, and other extreme supercars where every kilogram matters. Throughout its modern history, Tesla has optimized its vehicles primarily for mass production. Here, however, the company effectively has to learn how to build a low-volume exotic hypercar. According to sources, Tesla even brought in specialists with experience working in Italy, including engineers associated with Lamborghini. During the process, the Roadster's design went through some rather unusual stages. It is reported that von Holzhausen drew inspiration from the Lamborghini Countach and later wanted to give the car the character of the legendary Lockheed SR-71 Blackbird reconnaissance aircraft. This, according to the reports, is also connected to the project's A-71 designation. By the end of 2025, Tesla had reportedly built a running 2-seat prototype with butterfly doors. Therefore, the car Tesla eventually presents could be quite different from the red Roadster of 2017, photographs of which we have been seeing for almost a decade. Back in November 2025, Business Insider, citing people familiar with the program, reported that the current Roadster designs were 2-seaters and used butterfly doors, whereas Tesla had officially positioned the old concept as a 4-seater. And this is where the most interesting question arises. Why does Tesla even need this entire spectacle with rocket thrusters? After all, Tesla does not make its money from supercars today. For Tesla's business, the Model Y, Model 3, Cybercab, energy products, autonomous driving, and Optimus are far more important. Musk himself effectively acknowledged back in 2024 that the Roadster had to be placed behind projects that have a significantly greater impact on the company and the world. The answer is that the Roadster probably is not supposed to become a mass-market car at all. It is a halo car, a technological flagship. Its main purpose is not for Tesla to sell 1 million of them a year. Its purpose is to make people say again, how did they even do that? The first Roadster once served exactly this function. Tesla did not start with an inexpensive family electric car. It took a small sports car and proved that an electric vehicle could be fast and emotional. Then came the Model S, Model X, Model 3, and Model Y. Today, electric vehicles no longer surprise anyone. A 3-second acceleration time is no longer something incredible. Chinese companies are building electric supercars with more than 1,000 horsepower. And Tesla once again needs something so outrageous that simply making an ordinary electric car better is no longer enough. Hence the rocket engines. On the road, a car's performance is limited by the contact between its tires and the asphalt. You can install electric motors producing 2, 3, or even 4,000 horsepower, but all of that power still has to be transferred through 4 relatively small contact patches between the tires and the road. A rocket engine bypasses this limitation. It can push the car forward regardless of how well the tires grip the surface. If the car really accelerates from 0 to 60 miles per hour in less than 1 second, the average acceleration exceeds roughly 2.7 g, and that is already a physically demanding event for a human being. A few days ago, an event took place that could easily have been overlooked among the dozens of posts Elon Musk makes on the social network X. Musk did not hold a special presentation, roll out a new car on stage, or publish detailed technical documentation. Instead, he wrote just one short phrase that immediately triggered a new wave of discussion about Tesla's future. Elon Musk stated, "You will get flying cars." This phrase is particularly interesting because Musk was not talking about flying cars as distant science fiction that might perhaps appear several decades from now. The wording sounded much more confident and more like a promise that such technology will actually become a reality. Of course, 4 words on a social network do not constitute an official launch of a new Tesla program, but in Musk's case, statements like this are difficult to completely ignore, especially when we look at what technologies are currently available to the companies he controls. This short statement becomes much more interesting when we look at what is happening in China. While many American and European companies continue to debate how practical flying cars actually are, Chinese manufacturers are already investing heavily in their development. XPeng, through its aviation division Airage, is developing the modular land aircraft carrier system, which combines a large ground vehicle with a separate electric vertical takeoff and landing aircraft. The company has already publicly announced plans to scale production of this system in 2026. In other words, the flying car is gradually ceasing to be nothing more than a science fiction image from a movie. We are not talking about millions of people suddenly starting to fly over Beijing, Shanghai, Los Angeles, or New York every day tomorrow, but the technology has already reached the stage where major automotive companies are beginning to create real production plans, build factories, and demonstrate working aircraft. This is precisely why Elon Musk's statement could turn out to be far more significant than it initially appears. If Chinese automotive companies are already entering the new field of aerial mobility, then a perfectly logical question arises. Is Tesla really going to remain exclusively a manufacturer of ground transportation? The company has been developing far beyond conventional automobiles for years. Tesla is working on artificial intelligence, autonomous transportation, energy systems, robotics, batteries, and its own computing infrastructure. Therefore, developing an aircraft no longer looks like such an alien direction for the company as it might have seemed 10 years ago. It is particularly interesting to consider this possibility in the context of the Tesla Robovan. When Tesla first unveiled the vehicle, it immediately stood out even against the backdrop of the company's other unusual vehicles. The Robovan looks almost nothing like a conventional bus or minibus. It has no familiar large hood, traditional driver's cabin, or standard commercial vehicle proportions. What we are essentially looking at is a large futuristic capsule designed for autonomous transportation of passengers or cargo. Tesla officially describes the Robovan as an autonomous vehicle capable of being used to transport groups of people or various types of cargo. The philosophy behind this vehicle is already different from that of a traditional car, because a driver in the conventional sense does not necessarily have to be inside it at all. The vehicle is designed from the outset as part of an automated transportation system of the future. This raises an interesting question. If Tesla ever genuinely decides to create its own flying transportation system, could the company use the Robovan concept as a starting point? Of course, this does not mean taking the existing Robovan, installing 4 propellers on its roof, and trying to lift it into the air. A true aircraft would require a completely different structure, different materials, a different weight distribution, and an entirely different propulsion system. However, the exterior design, autonomous philosophy, and the very idea of a large transportation capsule could potentially carry over into a future aerial model. You can imagine a vehicle that visually resembles the modern Robovan, but has a significantly lighter body. Inside such an aircraft, there could be anywhere from 4 to 10 passengers. while several electric motors with large propellers could be positioned around the fuselage. During ground travel, the propulsion system would operate like a conventional electric automotive powertrain, while at a designated launch area, the vehicle would switch to flight mode, activate vertical thrust, and rise above the ground. This may sound incredible, but Chinese developers are already attempting to solve similar problems. The difference lies only in the approach. The Chinese land aircraft carrier essentially separates ground and air transportation into two parts. A large vehicle carries a smaller aircraft to the launch location, after which the aerial component separates and can perform an independent flight. Tesla could theoretically take a different approach and attempt to combine both functions into a single vehicle. This option would be more consistent with the company's traditional approach, which often involves reducing the number of separate components and integrating systems as tightly as possible. However, creating such a vehicle would be extraordinarily difficult because the requirements for a car and an aircraft are fundamentally different. An ordinary car needs to be structurally strong in a collision, have an effective suspension, adequate crumple zones, and sufficient mass for stability on the road. An aircraft, by contrast, needs to be as light as possible because every additional kilogram has to be lifted into the air using additional energy. This is why weight becomes one of the biggest problems for any electric flying car. In a conventional Tesla, a heavy battery reduces range and slightly affects performance, but the vehicle still remains on the ground. In a flying vehicle, the battery has to be physically lifted into the air together with the passengers, motors, cabin, wheels, and the entire structure. That is why battery energy density becomes a critically important characteristic. The more energy that can be stored in a single kilogram of battery, the farther the aircraft can fly or the more passengers it can carry. Tesla has enormous experience working with batteries, but even Tesla cannot escape the laws of physics. A modern battery remains much heavier than aviation fuel, containing an equivalent amount of energy. Electric motors, meanwhile, are extremely efficient, so part of the difference can be offset, but for long-distance flights, the weight problem remains fundamental. This is why the first mass-market electric flying cars are unlikely to be designed for journeys of thousands of kilometers. It would make far more sense to use them for relatively short routes, where traveling through the air can dramatically reduce journey times. Imagine someone who needs to get from an airport to the center of a huge metropolitan area. By road, the journey could take an hour and a half because of traffic. If autonomous air transportation can cover the same distance in a straight line in 20 minutes, the passenger gains an entirely different level of mobility. This is precisely where a flying Tesla Robovan could make sense. It would not need to replace the Model 3, Model Y, or Cybercab. It would not need to fly to the neighboring supermarket to pick up groceries. Such an aircraft could operate between major transportation hubs, airports, business districts, suburbs, and other locations between which thousands of people travel every day. If Tesla really does enter this industry someday, the most logical first product may not be a personal flying car that every individual keeps outside their home, but an autonomous aerial robo-taxi. Such a concept would fit perfectly with the direction Tesla is already moving in. The Cybercab is being developed as a specialized autonomous vehicle that could potentially operate without a traditional driver. The Robovan is intended to perform a similar role for larger numbers of passengers or for cargo. The next logical step, theoretically, could be a vehicle that uses not only roads, but also the airspace above them. In that case, the passenger would not need to know how to pilot the vehicle at all. They would simply open the Tesla app, select a destination, and receive an optimal route. If traveling by ground is faster, the system would dispatch a conventional Cybercab. If a suitable aerial route exists between the 2 points, the passenger could be offered a Tesla Aero, or an aerial version of the Robovan. The vehicle itself would automatically check the weather, airspace congestion, battery charge level, availability of a landing site, and the technical condition of all systems. After the passengers board, the computer would receive flight clearance, vertically lift the vehicle, and guide it along a predetermined aerial corridor. Autonomy could become one of Tesla's most important advantages if the company genuinely decides to enter the eVTOL market. It is virtually impossible to imagine a mass-market flying car as a vehicle that ordinary people would personally operate like an airplane. If every owner had to undergo extensive training and obtain a full aviation license, such a product would never become truly mainstream. The real revolution will happen only when flying becomes almost as simple for the passenger as taking a taxi is today. A person selects a destination, and the computer handles everything else autonomously. Tesla is already investing enormous resources into computer vision, artificial intelligence, and autonomous driving systems. Of course, you cannot simply take an automotive autopilot system and transfer it into an aircraft. The aerial environment requires an entirely different control system, different safety algorithms, and different sensors. However, Tesla's experience in building computing platforms and training neural networks could prove extremely valuable. A flying car would need to constantly understand its exact position in three-dimensional space. It would have to detect other aircraft, buildings, power lines, birds, construction cranes, and potential obstacles. The system would need to account for wind speed and direction, battery condition, weather, and available emergency landing sites. In addition, the vehicle would need to interact with air traffic management systems. If hundreds or even thousands of small autonomous aircraft are simultaneously operating over a major city in the future, they could not be managed according to the same principles used by conventional small aircraft today. A digital system would be required to allocate aerial corridors among vehicles in real time. The aircraft would need to know in advance at what altitude it was authorized to fly, where restricted zones were located, and which route would allow it to reach its destination while consuming the minimum amount of energy. If we look at Tesla's history, it becomes clear that the company has almost never limited itself to building only cars. When many people thought Tesla was simply an electric vehicle manufacturer, the company was already building some of the world's largest battery factories, developing its own powertrains, creating the unique gigacasting manufacturing system, investing billions of dollars in artificial intelligence, building its own supercomputers for training neural networks, developing the Optimus humanoid robot, and gradually launching robotaxis. At first glance, all of these projects may seem completely different, but in reality, they are part of one overarching strategy. Tesla is gradually transforming from an automotive company into a manufacturer of intelligent electric machines for virtually every purpose. That is why many analysts are now beginning to ask an intriguing question. If the company truly succeeds in bringing its autonomous driving technology, artificial intelligence, batteries, and electric motors to a new level, what will be the next stage of its development? What kind of device could have the same impact in 10 or 15 years that the first mass-market Tesla Model S or the future Optimus robot once had? Increasingly, one idea keeps appearing in these discussions: a compact personal electric aircraft that could one day become a new form of transportation. At the same time, it is important to point out that Tesla has not officially announced the development of such a device. As of today, the company remains focused on advancing artificial intelligence, robotaxis, Optimus, and scaling up production. However, if we look at the technologies Tesla has already created or continues to develop aggressively, it is fascinating to imagine what the next step might be if the company ever decided to enter an entirely new market. Today, Tesla already possesses one of the world's most advanced ecosystems of electric technologies. The company designs its own batteries, power electronics, software, inverters, cooling systems, electric motors, computing platforms, and proprietary AI chips. Moreover, enormous investments are now being directed specifically toward the development of autonomous systems and physical artificial intelligence. The company's latest reports show that Tesla continues to significantly increase capital expenditures on AI, robotics, and autonomous transportation, while management's primary focus remains on robotaxi, full self-driving, and Optimus. This is where a very interesting pattern begins to emerge. Virtually every advanced aircraft of the future will depend not so much on mechanical engineering as on software. Whereas engineers once competed in engine power, intelligence has now become the defining factor. A machine must perceive the world around it, recognize obstacles, make decisions in fractions of a second, calculate safe flight paths, anticipate the actions of others, and continuously adjust its position in space. This is exactly what Tesla has been working on for many years. Millions of vehicles collect enormous amounts of data every day, which are used to train neural networks. The company is effectively building a universal artificial intelligence capable of controlling complex physical systems. Today, that intelligence drives cars. Tomorrow, it operates Optimus robots. In the future, similar technologies could theoretically be applied to entirely different types of vehicles. This is why some experts believe that Tesla's greatest asset is no longer its cars themselves. The company's real value lies in its vast software platform, capable of making decisions faster than a human. The car becomes merely one platform on which that intelligence runs. The Optimus robot becomes another platform. If we imagine a compact electric personal aircraft, it would become a third platform running essentially the same intelligent system. That is why the creation of such a device no longer seems as unbelievable as it might have 10 years ago. Of course, the obvious question immediately arises: why Tesla rather than the established aerospace giants? The answer may be surprisingly simple. History shows that the greatest revolutions do not always originate within an existing industry. The automotive industry was fundamentally transformed by a company that was not a traditional automaker. SpaceX revolutionized the space industry, even though many believed it was impossible to compete with government agencies. Therefore, it cannot be ruled out that the next revolution in personal transportation could come not from conventional aerospace companies, but from a developer of artificial intelligence and electric platforms. Moreover, Tesla possesses an advantage that almost no one else has. The company already knows how to manufacture highly complex machines in the millions. Building a prototype is relatively easy. The real revolution begins when the cost of a technology can be reduced enough to make it affordable for ordinary people. That is exactly what happened with Tesla's electric vehicles. It is also what the company is trying to achieve with Optimus. If an electric personal aircraft ever becomes a reality, the decisive factor will not simply be its ability to fly, but the ability to manufacture hundreds of thousands or even millions of such vehicles every year. This is where Tesla's expertise in manufacturing automation, gigafactories, and gigapresses could become an enormous competitive advantage. However, the most fascinating aspect is the philosophy behind such a vehicle. Many people imagine a flying motorcycle as a replacement for a conventional bike, but in reality it could become an entirely new class of transportation. Imagine a vehicle that spends most of its time traveling on ordinary roads using existing infrastructure, yet when necessary can overcome small obstacles, traffic congestion, or difficult terrain through short, controlled flights or another form of movement that does not require continuous contact with the road. Such an approach differs significantly from a conventional airplane or helicopter and could potentially make transportation far more versatile. This is why companies around the world are already investing billions of dollars in electric vertical takeoff and landing aircraft technologies, even though widespread adoption remains a major challenge because of safety requirements, certification standards, and the energy density limitations of current batteries. What is most fascinating, however, is not the fact that such a vehicle could fly. The real revolution may lie somewhere entirely different. Throughout human history, virtually every new form of transportation was initially seen as an expensive toy for enthusiasts. That was true of automobiles, airplanes, personal computers, and even smartphones. But eventually there came a moment when the technology became affordable, widely available, and convenient enough that within just a few years it transformed the everyday lives of billions of people. That is why many experts believe that the next transportation revolution will be driven not so much by new propulsion systems as by a complete shift in the philosophy of mobility. Today, people must choose between a car, a motorcycle, a train, or an airplane. In the future, however, the boundaries between these categories may gradually disappear. A single universal electric vehicle could perform several different functions, automatically adapting to the specific situation. And if Tesla were ever to decide to create such a platform, it would almost certainly draw upon nearly every technological capability the company has developed over the past 20 years. First and foremost are batteries. Energy storage has always been the foundation of virtually every Tesla product. While most manufacturers purchase battery cells from third-party suppliers, Tesla invested enormous resources in developing its own energy storage technologies, improving battery chemistry, cooling systems, charging software, and manufacturing processes. Elon Musk has repeatedly stated that battery energy density remains one of the greatest challenges for the future. The more energy that can be stored without increasing weight, the greater the possibilities for any electric vehicle. For a car, higher energy density means a longer driving range. For an aircraft, it literally determines whether such a vehicle is even feasible. Every additional kilogram of battery increases the vehicle's weight, which requires more thrust, which in turn increases energy consumption. This creates a vicious cycle that remains one of the primary reasons why compact electric aircraft have not yet become mainstream. However, technology continues to advance. Each new generation of batteries becomes slightly more efficient than the last, while engineers constantly work to reduce costs, extend service life, and improve safety. Tesla's electric motors are equally important. Many people forget that the company has spent years refining its powertrain technology to achieve exceptional efficiency, compactness, and reliability. Modern Tesla electric motors are capable of delivering enormous power despite their relatively small size. Furthermore, the company has mastered the ability to control multiple motors simultaneously. In its all-wheel drive vehicles, the software continuously distributes torque between the axles, adjusting stability literally hundreds of times every second. If we apply the same philosophy to a hypothetical aircraft, it becomes clear that the system could independently control multiple propulsion units, instantly compensating for any deviations and maintaining stability. At that point, it would no longer be just a vehicle, but a massive computing system making thousands of decisions every second. This is precisely where artificial intelligence comes into play. Today, many people view full self-driving simply as an autonomous driving system for cars. But if we look more deeply, it becomes clear that Tesla is actually training a universal system to understand the physical world around it. Its neural networks analyze traffic conditions, recognize objects, predict human behavior, estimate distances, and make decisions virtually in real time. Such experience cannot be gained in just a few months. It has been accumulated over years through millions of kilometers of real-world operation. It looks like Tesla is preparing for one of the craziest presentations in the company's history. And this time, it is not about a new electric vehicle, a cheaper Model Y, or even a new generation of Optimus. According to fresh reports, Tesla may soon unveil a radically redesigned Roadster, with the centerpiece of the presentation being a technology that most people regarded as nothing more than another Elon Musk joke just a few years ago. The car is reportedly expected to demonstrate the ability to literally lift itself off the ground. Reuters, citing the information, reports that the presentation of the redesigned Roadster could take place as early as August 2026, while a special version of the vehicle could receive a cold gas thruster system developed using SpaceX technologies. Moreover, the demonstration is reportedly planned not on a conventional Tesla stage, but at the SpaceX test facility in McGregor, Texas. And this is where the story becomes far more interesting than the Roadster itself. Because if Tesla really demonstrates a vehicle capable of controlled vertical movement above the ground, even for just a few seconds, we may be looking at more than another expensive supercar. It could potentially represent Tesla's first major technological experiment in an entirely new direction, aerial transportation. And although there is currently no officially confirmed Tesla flying robotaxi project, the combination of several technologies being developed by the company makes such a scenario far less fantastical than it seemed just 5 years ago. On one side, Tesla now has an experimental vehicle equipped with a SpaceX-based propulsion system. Tesla has already begun production of the Cybercab in Texas, while fresh reports indicate that the company is preparing for a public launch of the vehicle in Austin, beginning with employee rides. The Cybercab was fundamentally designed as a specialized autonomous vehicle without conventional steering controls or pedals. This creates a very interesting picture. The Roadster could teach Tesla how to control a vehicle in three-dimensional space, while the Cybercab is supposed to teach Tesla how to hand complete control of a vehicle over to artificial intelligence. If these two branches are ever combined, They could create an entirely new category of transportation. Imagine a future Tesla AirCab. Externally, it might look less like a conventional aircraft with enormous wings and more like an enlarged cybercab with a fully enclosed cabin and several independent propulsion units. You open the Tesla app, select a destination, and the system automatically determines which part of the journey should take place on the road and which part should take place in the air. The vehicle autonomously drives to you, picks up the passengers, and travels several kilometers to a dedicated Tesla Air Hub, a small facility located near a highway or on the outskirts of a district. The system then locks the doors, checks the airspace around the vehicle, activates flight mode, and the vehicle rises vertically to an altitude of several dozen meters before entering a controlled aerial corridor. No pilot, no steering wheel, no instructions for the passenger. For the user, it is simply another ride ordered through the Tesla app. And precisely the absence of a pilot could become the greatest advantage of this type of transportation. On the other side, there is the Cybercab, a vehicle that was not designed for an owner at all, but as a fully autonomous transportation system. Tesla explicitly describes robotaxi as part of its autonomous future, while the Cybercab is being designed as a vehicle without a traditional driver. And if we combine the Cybercab's autonomy, Tesla's artificial intelligence, and the principle of thrust control that may now be tested on the Roadster, a remarkably interesting question emerges. What if the ultimate goal for the next decade is a Tesla that can not only drive itself, but also fly itself? Let's start with the Roadster. Tesla first unveiled this car back in 2017. The promises already seemed almost fantastical at the time. Acceleration to 60 miles per hour in approximately 1.9 seconds. A top speed of more than 250 miles per hour, and a range of around 620 miles. These specifications are still listed by Tesla on the vehicle's official page. But then, the Roadster became one of the company's longest-running projects. Years passed. The Model Y, Cybertruck, Tesla Semi, Optimus, and Cybercab appeared, while the new Roadster continued to remain somewhere behind the scenes. And that is precisely why Musk needs to show more than just another fast electric car now. Electric hypercars capable of accelerating in less than 2 seconds already exist. For the new Roadster to once again create the impression of a car from the future, Tesla needs to do something its competitors are barely doing. And that something could be the SpaceX package. The idea involves using several small gas-powered thrusters positioned around the vehicle. Such engines can potentially generate thrust almost instantaneously and could help the car accelerate, brake, stabilize itself, and even briefly lift off the ground. Fresh reports claim that within the project, the special package is designated by the codename A71 and that Tesla continued working on the system in 2026. At the same time, it is important to understand the scale of the experiment. This does not mean that the Roadster will become an ordinary flying car that an owner could take off from Los Angeles and land on the roof of a building in San Francisco. According to reports, the demonstration vehicle is expected to be operated remotely, and the version equipped with the thrusters may not be intended for ordinary roads at all. The reason is obvious. A powerful propulsion system creates completely different requirements for safety, noise, and the areas surrounding the vehicle. But for Tesla, that may not even matter, because in this case, the Roadster could serve as a technological laboratory. Historically, expensive sports cars have often been where manufacturers first tested technologies that were too complex or too expensive for the mass market. Carbon fiber bodies, active aerodynamics, sophisticated powertrains, new batteries, and electronic systems initially appeared on vehicles costing hundreds of thousands of dollars and only years later migrated into mass-market models. And the Roadster is ideally suited for such an experiment. Tesla can afford to install additional equipment in it, sacrifice some interior space, use expensive components, and not worry about whether the vehicle needs to cost $25,000. But if the system proves viable, the company gains invaluable data. How do you stabilize a vehicle during vertical movement? How quickly should thrust be redistributed between different engines? How should the electronics respond to crosswinds? What happens if one engine loses pressure? How does an autonomous system calculate a safe trajectory? How does the vehicle determine a suitable landing location? And this is where the Roadster unexpectedly begins to intersect with the Cybercab. The Cybercab is moving in the completely opposite direction today. If the Roadster is an extreme vehicle designed for a human driver, the Cybercab is essentially attempting to remove the human from the driving process entirely. Most air taxi projects today face not only the challenge of building the aircraft itself, they also need to train pilots, pay their salaries, limit their working hours, and create air traffic management infrastructure. An autonomous Tesla could theoretically eliminate one of the most expensive components of this system. And this is precisely why autonomy could potentially be even more important for aerial transportation than for road transportation. On the ground, a person can call a conventional taxi virtually at any time, but the market for individual air transportation remains practically inaccessible to the average person today. A helicopter is too expensive, too noisy, requires a pilot, extensive maintenance, and specialized infrastructure. An autonomous electric flying taxi is attempting to turn flight from an aviation service into an ordinary transportation journey. And this is where the scale of the potential changes becomes enormous. Today, distance in a city is measured not in kilometers, but in time. 10 kilometers through the center of a major metropolis can take an hour. 30 kilometers between a suburb and a business district in the morning can turn into a 90-minute commute. An air taxi could fundamentally change this mathematics. It would not need to follow the configuration of roads, wait at traffic lights, or sit in traffic jams. A 40-kilometer route could become almost a straight line. This means that neighborhoods currently considered too far from the city center could suddenly find themselves only 15 minutes away by air. And the consequences would go much deeper than simply saving time. The structure of cities themselves could change. Today, property values are heavily influenced by transportation accessibility. People pay a premium for housing near city centers, subway stations, or convenient highways. If autonomous air taxis ever become widespread and relatively affordable, the importance of physical distance could diminish. People could live much farther from their offices, airports, or city centers and still reach them faster than someone living within the city. Huge parking lots around airports could gradually become autonomous transportation hubs. Railway stations could acquire dedicated air taxi landing areas. Shopping centers, business parks, and large residential complexes could begin designing their own landing zones. But Tesla potentially has another advantage that most air transportation startups do not. The company is already building virtually every major component of the necessary ecosystem. It has electric vehicle manufacturing, it has its own battery technologies, it has automotive artificial intelligence, it has the robo-taxi app, it has charging infrastructure, it has Tesla Energy, and next to it is SpaceX, with enormous experience in thrust control, engines, gas systems, and automated motion control. In recent years, the global automotive industry has been undergoing a transformation on a scale that until recently seemed impossible. Just 5 to 7 years ago, Chinese cars were perceived as a compromise option, often inferior in quality, technology, and prestige, compared with Western and Japanese brands. But today, the situation has changed dramatically, and according to analysts from leading consulting agencies such as McKinsey and Bloomberg Intelligence, China has not simply caught up with its competitors. It has started setting new rules for the entire industry. Chinese automakers have rapidly transformed into technological leaders, setting the pace for the development of the entire sector. And now, after the electric vehicle segment has been almost conquered, Beijing is taking the next step, a far more ambitious one. According to sources close to Chinese government circles, the country is discussing a new long-term strategy for the development of future transportation, where the key direction will be the integration of ground and aerial mobility. The idea involves creating hybrid vehicles capable not only of moving on roads, but also of taking to the air, covering thousands of kilometers without being tied to traditional infrastructure. This concept has already received the unofficial name three-dimensional mobility and is being considered as the next logical stage after mass electrification. Against this background, BYD is once again at the center of attention, one of the largest players in the global electric vehicle market and an undisputed leader in battery technology. Just a few years ago, BYD remained in the shadow of names like Tesla and Volkswagen. But today, it not only competes with them, but confidently surpasses them in certain segments. The company controls the entire production cycle, from battery development to vehicle assembly, giving it a unique advantage in the race for the transportation of the future. According to information published by several Chinese technology media outlets and confirmed by industry insiders, BYD has already begun laying the foundation for entering the flying transportation segment. This is not yet about a finished product or an official announcement, but sources claim that the company is actively investing in research into lightweight composite materials, highly efficient electric motors, and vertical takeoff and landing systems. All of this is directly connected with eVTOL technologies, electric aircraft that are considered the foundation of future flying cars. Experts note that the transition to flying transportation could radically change not only the automotive industry, but also global logistics as a whole. Imagine a world where the distance between cities no longer matters. A journey that today takes 5 to 6 hours by car could be reduced to 40 to 50 minutes through a direct aerial route. Mountains, oceans, deserts, and megacities would cease to be barriers. Transportation would move along the shortest trajectory, bypassing traffic jams, infrastructure limitations, and geographical obstacles. For China, this opens enormous opportunities. A country with a vast territory and dense urbanization would gain a tool capable of connecting remote regions with major cities with almost instant accessibility. According to Goldman Sachs analysts, the introduction of aerial mobility could increase the efficiency of China's domestic economy by tens of percent through faster movement of people and goods. However, behind this futuristic vision lies an extremely complex engineering challenge. A flying car is not simply a vehicle with wings. It is a hybrid of two systems with completely different requirements for safety, reliability, and control. It must be light enough to take off, but at the same time strong enough to withstand road loads. Its power system must provide vertical takeoff, horizontal flight, and road movement, all without losing efficiency. Batteries play a critical role here, and this is precisely where BYD has a major advantage. The company is one of the largest battery manufacturers in the world and is actively developing its own technologies, including solid-state batteries and new types of chemistry with increased energy density. According to experts, battery energy density remains the main limitation for the mass adoption of flying cars. For such transportation to become a reality, it must provide sufficient flight range while maintaining minimal weight. Another important aspect is safety. Unlike conventional vehicles, a system failure in the air could lead to catastrophic consequences. Therefore, developers are forced to implement multiple layers of redundancy for all critical components, from motors to control systems. This significantly increases the cost of development and production, which automatically makes the first flying car models extremely expensive. According to preliminary estimates, the price of the first mass-produced models could reach $300,000 to $500,000 per unit, making them available only to a limited group of customers. However, just as with electric vehicles, experts expect prices to gradually decline as production scales up. Another major challenge is regulation. The introduction of flying cars requires the creation of completely new infrastructure, from dedicated air corridors to urban air traffic management systems. Governments will have to develop new safety, licensing, and certification standards. In China, this process has already begun, and according to insiders, the government is considering creating pilot zones where testing of such vehicles will be allowed. Interestingly, BYD is not the only player in this race. Companies such as Xpeng Aero HT have already demonstrated working prototypes of hybrid transportation systems capable of separating the flight module from the ground chassis. Nevertheless, analysts believe that BYD's scale and manufacturing capabilities could allow the company to bring the technology to the mass market faster than others. According to forecasts from industry experts, the first limited versions of flying cars could appear by the end of the current decade, while mass adoption is not expected before 2035 to 2040. By that time, battery technologies, autonomous driving systems, and aerial infrastructure will need to reach the required level of maturity. And if these forecasts prove correct, humanity is standing on the threshold of a new transportation revolution, one comparable to the emergence of the automobile or the airplane. And it is entirely possible that one of the main drivers of this revolution will be China, a country that in just one decade has transformed from a follower into a technological leader. And, as analysts point out, if the world once asked whether China could catch up with the West, today the question sounds different. Can the rest of the world keep up with China in the race toward a future where roads are no longer limited to the ground and transportation rises into the sky, opening a new era of mobility? And as this concept begins moving from theory into practical implementation, the industry is increasingly asking not, is this possible, but rather, who will do it first? Within the Chinese technology community, the belief is growing that the window of opportunity for a breakthrough is open right now. Several factors have aligned at once: the rapid development of artificial intelligence, progress in autonomous control systems, a revolution in battery technologies, and unprecedented government support for innovation. Sources close to the research divisions of Chinese corporations claim that the largest automakers are already conducting closed tests of individual components for future flying platforms. These are not complete vehicles yet, but key modules, stabilization systems, thrust distribution, intelligent autopilot capable of controlling a vehicle in three-dimensional space. Essentially, a new transportation ecosystem is being created, where a car stops being just a means of transportation and becomes an autonomous flying module with a wheeled base. Artificial intelligence plays a special role in this process. Manually controlling a flying car is a task that requires pilot-level skills, which automatically limits the mass adoption of the technology. That is why developers are focusing on fully autonomous systems that will take over the entire process, from takeoff to landing. According to analysts, without powerful AI, large-scale implementation of flying cars would simply be impossible. In this context, the strategic logic behind the actions of companies such as BYD becomes clear. Even if today they are not presenting finished prototypes, they are actively investing in related fields: batteries, electronics, power systems, and software. This creates a technological foundation that can later be quickly converted into a complete product. Essentially, a hidden preparation for the next technological leap is already underway. Insiders also note that China views flying transportation not only as a commercial opportunity, but also as an element of future national infrastructure. Inside the country, projects involving vertical cities are already being discussed, where building rooftops would serve as landing platforms, and movement between districts would take place through aerial routes. This completely changes urban architecture and the principles of city planning. But the closer this future becomes, the more clearly new risks begin to emerge. One of the key challenges is air traffic management. If thousands or tens of thousands of flying vehicles simultaneously take to the skies above a megacity, an entirely new coordination system will be required, capable of tracking and managing every object in real time. In recent months, something has been happening inside Tesla that analysts are already calling the most extensive product overhaul in the company's history. According to sources close to management in Austin and Fremont, as well as information reportedly confirmed by several independent publications, including Bloomberg and The Information, the company is preparing not merely an evolution of its existing models, but a fundamental restructuring of its lineup around a new philosophy of mobility. The shift would be from conventional vehicles with steering wheels to fully autonomous platforms in which the human becomes a passenger rather than a driver. One of the most high-profile elements of this transformation, according to insiders, will be an updated Cybertruck featuring a design language similar to the Cybercab currently being tested on public roads, with certain configurations reportedly offered without a steering wheel or pedals at all, provided regulators grant final approval. But it was an entirely different detail that generated the biggest surge of interest. According to people directly familiar with work at Tesla Cyberlab and parallel developments at SpaceX, one of the most unusual and carefully concealed areas of development has allegedly been the so-called flying mode, a flying version of the Cybertruck. This would not be a full-fledged aircraft or a conventional eVTOL, like those being developed for certification by companies such as Joby or Archer. Instead, it would be a vehicle that remains a pickup truck, but can briefly lift off the ground, cross impassable terrain, clear ravines, debris, deep water crossings, or damaged roads. According to engineers, this particular scenario makes the Cybertruck an ideal platform. Its angular stainless steel exoskeleton, substantial structural strength, high ground clearance, and existing 48-volt electrical architecture would supposedly allow a thruster package to be integrated without completely redesigning the body. Sources within the company describe the concept this way. The Cybertruck would be able to transform by deploying compact thruster modules that are allegedly undergoing bench testing inside secure Cyberlab facilities. These modules would use cold gas and high-pressure cylinder technologies developed by SpaceX and would be designed not for sustained flight, but for brief vertical lift. The intended altitude would be roughly 1 to 1.5 meters, with a maximum of several meters in an emergency situation. Flight time would range from several seconds to perhaps a minute and a half. The goal would not be to replace a helicopter, but to give the owner the ability to literally jump over a difficult off-road section that a conventional pickup could no longer cross. For people who travel outside cities, work on construction sites, live in regions with poor roads, or simply want maximum off-road capability, such a system would represent a decisive advantage. That is precisely why insiders allegedly describe the Cybertruck as the best candidate. Its mass, geometry, and existing power architecture could supposedly allow the thruster system to be concealed in such a way that the vehicle would retain the appearance of a pickup rather than becoming a flying drone. This would, of course, be an extremely powerful marketing move. The first production vehicle officially capable of lifting off the ground, even for a short period, would automatically become a major media sensation. Tesla already commands enormous market attention thanks to the Cybercab, which is reportedly undergoing engineering tests without a steering wheel on the streets of Austin, as well as Optimus. But a flying Cybertruck would represent an entirely different level. According to estimates from several analysts close to funds investing in Tesla, simply demonstrating such a mode at a presentation could generate a media impact comparable to the launch of the original Model S or the unveiling of the Cybertruck in 2019. Reuters, citing sources in investment circles, has reportedly noted that interest in possible SpaceX packages for the pickup increased dramatically after the first photographs and renders of a golden prototype equipped with thruster modules allegedly appeared in private channels, showing the vehicle hovering above the laboratory floor. However, behind this attractive picture lies an entire complex of extremely difficult technical, regulatory, and legal problems. And this is where the most interesting, but also the most challenging part of the story begins. The first and most important difficulty is the technology itself. Creating a thruster capable of lifting a vehicle weighing nearly 3 tons even 1 meter off the ground is no longer automotive engineering but rocket engineering. According to engineers who have previously worked at both Tesla and SpaceX, the high-pressure cylinders required for such a system would have to withstand pressures of around 10,000 pounds per square inch. Any flaw in the material, welding, or pressure release system could turn the thruster into a potential bomb. In addition, real-time thrust vector control, stabilizing the vehicle in mid-air during crosswinds, and automatically canceling the vehicle's momentum during landing would all require an entirely new level of software and sensor technology. Tesla, of course, has enormous experience controlling vehicle dynamics through FSD, but this would already involve the dynamics of an aircraft. Sources reportedly confirmed that the team working on the thruster package partially overlaps with engineers who previously worked on cold gas systems for the Roadster, but the scale and safety requirements for the Cybertruck are said to be an order of magnitude greater. The second problem is regulation. This is where things become even more complicated. To sell a vehicle without a steering wheel, Tesla is already going through a lengthy regulatory process involving NHTSA and individual states. The Cybercab has already received a number of approvals and is undergoing road testing, but even in this case, the process is moving more slowly than Elon Musk had promised. For a flying mode, The situation is fundamentally different. As soon as the vehicle leaves the ground, it ceases to be an automobile in the legal sense and becomes an aircraft. That brings it under the jurisdiction of the FAA. It would require either a special category for a light aircraft under the relatively new Mosaic framework or full certification under the rules governing powered lift aircraft. In Europe, EASA requirements are even stricter. The probability of a catastrophic failure would have to be on the order of 10 to the minus ninth power, meaning approximately 1 failure per billion flight hours. By comparison, ordinary automobiles operate under an entirely different set of standards. Then there are licensing requirements. The owner of such a Cybertruck would not simply be able to get in and take it for a flight. Most likely, either a special pilot license for a light aircraft would be required, or the vehicle would have to be certified as a fully autonomous aerial vehicle, something that does not yet exist on a mass-market basis. Local authorities, insurance companies, airspace regulations over residential areas, restrictions on urban flights, noise requirements, and emissions regulations, even if the system uses cold gas, would all create a multi-layered regulatory barrier. According to estimates from lawyers specializing in advanced air mobility, even if Tesla unveiled a perfectly functioning prototype tomorrow, the path to the first legal sale to a private individual could take between 5 and 8 years, and potentially longer in some jurisdictions. The third challenge is economic and manufacturing related. A thruster package would not be cheap. High-pressure cylinders, valves, control systems, a reinforced frame, and additional electronics would all sharply increase the cost of production. According to preliminary estimates from analysts who have reportedly seen internal documents, a flying Cybertruck configuration could cost $40,000 to $70,000 more than the base version. At the same time, demand for such a variant would most likely be limited to a narrow group of enthusiasts, off-road clubs, and corporate customers who require maximum off-road capability. It is unlikely to become a mass-market product in the coming years. This creates the risk that the project could remain a technology demonstrator or an extremely expensive option, much like the SpaceX package once envisioned for the Roadster. Despite all these difficulties, however, the project apparently has not been abandoned inside Tesla. Several independent sources have reportedly confirmed at different times that bench testing of the thruster modules is continuing, that functional prototypes exist, and that at least one full-scale prototype has already lifted off the laboratory floor to a small height. It is precisely footage of this kind, a golden Cybertruck hovering on thrusters inside the pristine white Cyberlab beneath the Tesla logo, that has reportedly begun leaking into private chats and specialized forums. Officially, the company has so far made no comment, but the absence of an official denial despite this level of leaks is, in itself, already telling. For those who follow Tesla, this story is particularly interesting because it fits perfectly into the company's broader strategy. A fully autonomous cybercab without a steering wheel represents the future of urban mobility. A Cybertruck with a thruster mode represents the future of extreme mobility beyond the city. Together, they paint a picture of Tesla moving beyond being simply an automaker and becoming a company that redefines the very concept of transportation. And even if the flying version ultimately turns out to be heavily restricted, limited in duration, and available only after a lengthy regulatory process, the mere fact that Tesla is seriously working on a vehicle capable of leaving the ground would already change the rules of the game in the industry.